Uh, we're doing some malware today, so like this is gonna be a long one, a long video probably. Um, I know it already, just because I know the difficulty of what we're going to be doing. So yeah, wait, let me just actually fix this thing that I was doing to test here, right? Okay, so let me show you what I'm doing, what malware I'm working on. It's testing malware to see like if I can develop it. I've been working on it for the past like Jesus, couple of weeks. And yeah, so this is how it works. Here's my server. That's on somewhere here. 192.168.1.108. It's on the same network as my Windows computer, and then here we have our VM or victim VM, which simply fuck off. Which simply it's just before the disaster, before I took a snapshot. It's simply the one we'll be experimenting on and having fun with. So like I have a shared space, so that I can upload the malware over there and like experiment on this VM. And in case something gets fucked up, I just have a snapshot ready. So yeah. Okay. Well, that's pretty cool. But what kind of malware am I developing? Well, no particular. Nothing in particular, to be fair. It's I'm going without a clear goal in mind, so yeah. But in general, here, let me show you. Here I have my backend. It's based on REST APIs, by the way. I'm not sure if that's the best implementation, but probably not, but oh well. So it's running on Node, the backend. The malware is called Pivoter, by the way. You have Pivoter server, and that's running on the server to capture information, and the Pivoter client, which is the actual virus, the actual spyware, whatever. So if you run it, here it is. I enable debug so that there is this window and it tells you what's happening. Simple as just tells you what's happening, like logs all of your keys. It's basically, for now, it's a simple keylogger, and every 100 keys it will send them to the Pivoter server. So now if you take a look here, you can see that the node got the keys, and yeah, we can take a look at them. They're basically the same data. So yeah, that's the theory behind it. Every 100 keys it just sends them, and yeah, the array, or in this case the vector, gets cleared. So it's using curl, the curl lib. You can see here the imports, and yeah, what I'm doing is taking the vector, joining it in a string with alongside like the space, and base64ing it and sending that as a post request to the server, which is running here. Like, this is the code for now. Simple as this, bro. Like, it can be simpler than this. It's URL encoded. I mean, not that it matters since we're doing base64, but okay. I've been also thinking about implementing, like, since this is pretty fucking insecure, if, let's say, if somebody would start listening for, or would start wiretapping or whatever with Wireshark, they could interfere. They could see the messages, and they could see their own keys being tapped and logged. It's not the best implementation with just base64, so what I'm trying to do in this episode, what I will do, is encrypt the traffic. I think I could implement it via like HTTPS, just, I don't know, somehow encrypt it and whatever, and then do that. But that wouldn't be fun. And doing my own encryption, I mean my own way of encrypting, would give me much more control. So I think I will go with that way. Although I can still enable HTTPS on the server, and that will solve the issue. But yeah, okay. Let's see how we can implement AES for the traffic. Now, the function where it sends the codes is this. Inside of the connections pivoter, send codes, and it's easy like this. Curlib the curlib documentation was very helpful and very easy to understand. It's really it's really not rocket science or whatever. It's pretty straightforward. Here you set some flags, which are basically literally like command line flags. Like the target URL, the posts field, and then you just perform the request. If it fails, return false, else return true, whatever. Also, let me write here an actual check for the debug thing. If we are on debug true, let's see. Response. If we're on debug, let's see, std count and failed sending message to the mother server. That's how I call it. SD and line. Also, we need another check if res is false. Okay. After that, let's see. We have to implement AES encryption. Now, I've already taken a very quick look at how AES works on the Windows API. So this is the Windows documentation. We will be using CNG, which is a cryptography API. I don't know how to read, sorry. Cryptography API. Bro, whatever. Yeah, the next generation. There was the previous one. Ayo, crypt.api, crypt API Windows. Let's see, what was it called? Crypt API, cryptography, crypt encrypt. What the hell? Ayo. WinCrypt. Yeah, this was a thing, but as I was told, it's outdated. So yeah, we're using CNG. And yeah, here I went to encrypting the data, the example, and I guess we have to understand how this works. Here under the typical CNG programming, there's the typical steps written, like how it works: opening the algorithm provider, getting the setting algorithm properties, creating and importing a key, performing cryptographic operations, closing the algorithm provider. So we would need a key because we're working with AES, of course. The key, I don't know, either we can hard code it or fetch it from the server. No, that wouldn't be nice. For now we will hard code it probably. Okay. So we'll be hard coding it, and okay, here we have the main function. We're setting the stuff, not me not knowing what this is. Okay. Open the algorithm handle. This, which is this, yeah. I've already taken a look at this. Function that loads and initializes the CNG provider, which is basically this. We are doing the first step. Okay, so let's see. Wait, let's go through this. Pointer to the bcrypt algorithm handle variable that receives the CNG provider handle. Okay, basically this received. Okay. Finish using this handle, release it by passing the... Okay, so this is how we'll close it, which is exactly what we have to do at the end. PSZ algorithm ID, this is probably the ID of the algorithm. Pointing to an alternated Unicode string that identifies the requested cryptographic algorithm. AES algorithm. Okay, yeah, perfect. Then PSZ implementation, pointing to an alternated Unicode string that identifies the specific provider to load. Specific provider to load. This is the registered alias for the cryptographic primitive provider. This parameter is optional and can be null if it's not needed. This parameter is null, the new provider specified algorithm will be loaded. What the fuck? Bro, this is where it gets shit fucking hard to understand what they mean. Goddamn. Okay, let's try to do the shit. Let's see. Okay, so here we have the. Okay, we need to base 64 and actually not gonna comment. Let's see. Keys message base 64 encode keys message, and I'm gonna remove this. Simple as this, and then encrypt it. So here we have to do the stage of actually encrypting it. I'm gonna do a simple add a simple function to encrypt actually the stuff. So let's see. Function that let's see, encrypt the codes, the key codes. Param name. Probably need simply the data to encrypt. Returns. Okay, that's nice. Let's see. Returns what will return. Simply the data. Actually, should it be string? I don't know. Okay, whatever. For now, it's a string. SD string encrypt traffic. SD string. Let's call it just data. Okay. Should we also have a decrypt function? Nah. For now, we don't need it. Okay. We should also have a key. Although, what's the key type? Allocate the key object on the heap. Wait, is this public key? What the hell is this? I mean, it's probably just a key. Okay. This is a p byte, whatever this is. Microsoft documentation p byte. The hell? Windows data types. A pointer to a byte. Okay, I see. This type is declared and when def as false. Okay, so it's a basically a pointer to a byte. Wait, what the fuck? Okay, and how large is this gonna be? Key size AES. Advanced encryption standard keys are symmetric keys that can be 3 different lengths. Yeah, but which one of those? What the fuck? Oh boy. Okay, let's try just to just do the first one for now. Okay, opening the algorithm provider. So we need to call this and the status, and if it fails, let's see how to check. Okay, basically if okay, NT success is basically just a function. No wait, yeah, okay. NT success status bcrypt. Okay, I also have to include shit. So let's see what do I have to include. Bcrypt, just bcrypt. Okay, bcrypt.h. That's nice. If anti status, surprisingly, it's still not there. Because anti success. Okay, anti success. It's still not there. What the fuck? That's strange. Am I missing something? Oh, define anti status. Okay. Me trying to understand what this means. I mean, it's basically a I think those are called macros. I don't fucking know. I'm not the expert. An expert in C++. So if anti-status is higher than 0 or equal to 1, that's okay. If it's below, it's gonna be a problem. Okay, I mean, we can actually check it here. How is it gonna fail? How is it gonna fail? Success not valid, status not defined. Bro. Documentation, Microsoft. Anti-status values, okay. This seems promising. What the hell? Let's see, let's convert this to decimal. Oh lord! Decimal from to cent comp. Okay, what the fuck? So yeah, basically, if it's under 0, I mean above 0, it's okay, including 0, of course. So yeah, okay. So now I can go here and let's see. Status is gonna be a anti-status. With the status. Bcrypt. Whatever is this? Get property. Bcrypt get property. Yep. Okay, we need the handle, the property, the output, the output. What the fuck? Okay. Let's see. Although, what the fuck? Wait, bcrypt open algorithm provider. It's the wrong one. Yeah, it's the wrong one. Oh yeah, because I'm doing the other one. Bcrypt open algorithm provider. So I need the AES algorithm. I mean the actual handle. So bcrypt. Now we have to specify it. So bcrypt handle algorithm handle. Bcrypt algorithm handle. Have to pass the pointer alg handle. What now? The algorithm ID. Okay, so of course the bcrypt AS algorithm. Then okay, null and 0. God damn. Okay. Although I wonder what kind of other algorithms there are in here. So let's see. Maybe we might find something even better. Okay, 3 this. Okay, 3 this. Whatever. AS. The encryption systematic standard. Standard FIPS. Is this how big the Yeah, probably how big the key is. Wait. No, never mind. Lol. What else do we have? Okay, and oh, we have also hashing functions. That's nice. RSA, SHA. Okay, it's cool. That's cool. But we are cool with simply yes. So let's do the check if status is higher or equal to. It's actually lower than 0. We are going to let's see. Let's leak out. Okay. Dear fuck, I need to share it. I need to share the goddamn thing, but okay, for now let's just do this. Okay, then the next thing that we have to do is getting and setting the algorithm properties, which I have no idea what they are. Allocate the key. Okay, probably it's the key. Calculate the size of the buffer to hold the key object. Okay, I guess that's setting up properties. Calculate the block length of the IV, whatever that is. Determine whether the what are the next one? Okay, creating and importing the key. Okay, whatever. So we're probably skipping. Let's see what this is. We're probably skipping the second step, I'm assuming. Retrieves the value of a named property for a CNG object. Okay, so you tell it which property. The output, what the hell is this? Let's see. Hello represents the, okay, a pointer to the null terminated Unicode string that contains the name of the property of retrieve, okay. The address of a buffer that retrieves the property value. CB output size bytes, okay, yeah, okay. PCB result, wait. Okay, so that's how much we are going to take. Okay. PCB result. A pointer to a ulong variable that retrieves the number of bytes that were copied into the PV out buffer. Okay, and don't worry, flags. A set of flags that modify the behavior of its function. No flags are defined for. Okay. So we're going to be taking the property, whatever, the key object. What the hell? And then we are putting it there. I mean, we're allocating the memory and probably then putting the key, because this is probably the step that in which we're importing the key. So let's see. Status bcrypt get property the algorithm handle. Then we need the bcrypt object length. What the hell? So that's what we are actually taking. The fuck? Wait, let's see. Wait, no, where the hell is it? Did I close it? No, I did not. Well, I'm gonna reopen it. Okay. Okay, so we're retrieving the object length. Whatever this object length is, because I have no idea what this is actually. Either the length of the whole. The following values are used to identify a property. The total property is used to obtain this information. Key object length. So Why is it called this way? What the hell? If you're getting the key length, then you should... Okay. Locate the key object on the heap. What the fuck? This is actually heap allocate. Wait, what does heap allocate do? I mean, okay, does it return? Let's see. Oh god. Okay. It returns a long pointer. Return value points to the allocated memory block. Okay. So why the hell we are? Oh no, because we're using. Okay. Let's see where this is used. Here. Allocate. Oh, okay. I see why. I see why we are using it. Because we need to allocate that much memory. So I thought it was something else. Whatever. Bcrypt object length. Is that it? Yeah. Okay, so p byte to the key object length. Size of d word, cb data, whatever that is. For now, let's keep it null and 0. First, we have to define the upper one. Let's see. P byte key object length. Okay. And then we need to allocate this. The actual key object, I'm guessing. Oh shit, this is gonna be a D word, okay. Lol. P byte key object. Okay, so this is a CB key object. Yeah, that's it. Okay. CB output, the address of a buffer that retrieves the property value. Okay. Fair. Fair. Now let's see what this does. The PCB result appointed to the ulong variable receives the number of bytes. Bruh. Do I need it actually? Yeah, because maybe we have to... No, actually not. I mean, if we don't actually need it for anything specific, so we can just remove it. I mean, keep it 0. Is it safe to keep it null though? I don't fucking know. Let's just do it for now. Actually, let me try to see if this would even work for now. Yeah, okay. It ran. That's nice. So okay, after doing this, we have to check if status is probably this. Yeah. Okay. SD count error of getting the length of the key object. Let's see if there was an issue with it. Oh shit! What's green, bro? Status holds a variable that must be examined. Bruh. No thank you. I'm getting the length of the key object. Okay, maybe I have to fucking take it. Let's see. 1, 2, 3. 1, 2, 3, 4, 5, 6. 3, 4, 5, 6. Okay, nice. Then why the hell? CB, so bytes, status bytes. Let's do it like this and just put the location of it and go here and status bytes. Okay, what type is this? D word. Let's see, status bytes. Bruh. Okay. Okay, now it works. Apparently, I actually have to pass and a pointer. I mean, a pointer. Yeah, a location. So let's see. Next thing we have to do what? To allocate. Yeah, allocate the stuff. So key object heap allocate. Wow, a nice p byte. That's nice. P byte. Oh shit. Okay. Get process heap. The fuck? Heap handle to the heap from which the memory will be allocated. Okay. So I basically have to copy paste this. Get process heap. Then what the hell? What is this? Don't worry flags, don't worry bytes. Okay, so how many bytes and the flags? So this and probably the key object length should be passed. Let's see. CB key object, which is exactly this. Yeah, okay. So if null, we fail to allocate. If null key object std count failed allocating memory for the key object. std and line. Okay, nice. The fuck? Oh yeah. Okay. That was intense. Now I think we have to calculate the block length for the IV. Block length, whatever that is. Like how much, how blocky it has to be. No, I don't fucking know. Let's see what this is. No, not the property. Wait. This. Bcrypt something. Bcrypt block length, the size in bytes of a cipher block of the algorithm. This property only applies to the block cipher algorithms. This type is a D word. I'm not getting it. What the fuck? What's this? Okay, a cipher block. I think I have to understand how AES works in this part actually. So fuck. Block cipher. In cryptography, a block cipher is a deterministic algorithm operating on a fixed group of bits called blocks. Block ciphers are specified elementary components in the design of many cryptographic protocols that are widely used to encryptate large amounts of data. Okay, nice. Including in data exchange protocols, a block cipher uses blocks as an unvarying transformation. That's okay. Even a secure block cipher is suitable for the encryption of only a single block of data at a time, only a fixed key. So this is like basically the... Wait, what the fuck? This property is... no, wait, this is the object length. What the fuck am I reading? Block length. Size of a cipher block for the algorithm. The fuck is a cipher block? It's an algorithm. It's an algorithm. I don't see how this could have bytes in it. Operating on a fixed cipher called base. Maybe this is like the actual thing. Called blocks. Okay. Block ciphers are blocks. A block cipher uses blocks and another way in transformation. However, block ciphers may also feature as building blocks on other... Oh my god. Jesus Christ, they're also the building blocks of shit. Okay, over a set of input blocks. Bro. Most block cipher algorithms are classified as iterated block ciphers, which means that they transform fixed size blocks of plain text into... Oh! Oh, wait, what? Oh shit. Okay, I don't understand a lot of that, but okay, wait. The size in bytes of a cipher. What the fuck? Bro, are you drunk? I don't understand this. What the hell? I'm dying. A sketch of a substitution permutation network with 3 rounds encrypting a plain text block. Oh! of 16 bits in a cipher's text block of... Oh fuck, no, wait, what? The S blocks are the... I think I should have checked out how AES actually works for this shit. You know, Kevin, goddammit. The S boxes are the S. Okay, and P boxes are the same P, and the round keys are K. Oh my lord. Network. What are blocks? AES what? Block ciphers. A symmetric block cipher chosen by US. No, not the actual thing, bro. Give me the... What are blocks? The block size is talk or the bytes, so plaintext form of... Okay... What? But this is like the size. How like a block will be block for the text, block for the key, block for whatever. What, like block for what? What is gonna be? For key size and block... Oh, block size, so it's the data. Let's see, okay, we're working on AES and we want to develop a website which should provide an encryption facility, but we are not understanding the difference between key and block size. More appropriately, what does 100, 200 bit mean? Okay. The key size is simply the amount of bits in the key. With AES, like most modern block ciphers, the key size directly relates to the strength of the key algorithm. The higher the stronger, since all bits are used. There are... What the fuck? Bro... There are two to the clan, okay, possible keys, taking... Okay, operations to force on average. Phrase, the internal key schedule, okay, but I need to block. Okay, the block size is simply the amount of bits or bytes that can be transformed by the block cipher. It is the input and output size of the keyed block cipher. This transformation is called the keyed permutation, as each plain text has a corresponding cipher text, and vice versa for a specific key. What the fuck? For AES, the block size is okay. So that's how much. So plain text from a set of goddamn possible plain text is permuted to a single cipher text from the set of... Okay. Block cipher is not a generic cipher. Wait, a block cipher is not a generic cipher. A mode of operation is required to use the block cipher to confidentiality. Although the block size is not directly related to the security of the block itself, it doesn't affect the security. It does affect the security of the mode of operation that the block cipher used. And what the fuck am I reading, bro? Jesus Christ! This is gonna be just 1 hour of me complaining about how to fucking learn AES. The related key attacks on... Oh boy. AES can be used to provide protection against... Oh my god, no, I'm not gonna read all of this. Well, I think this is the most important part, like the most interesting. But still, I am missing something, like, is this actually the text that's getting in? Like, I don't understand. The block size is simply the amount of bits and bytes that can be transformed by the block cipher. So like per each every time, so like if you have the input, it's gonna pass it. Oh my god, this is intriguing. So like if you have text, like shit, and only one character, for example, only one byte could be passed at a time, because it's a 1 byte cipher, one byte. The block size is simply 1 byte. It would be passed. It would firstly encrypt S, then H, then I, then T. And if you had like shit test 2, like and the block size would be like, I don't know, like, wait, 1 2 3 4 5 6 7 8 9 10 11 12. Okay, you would have like 4 bytes. It will firstly elaborate, then ST. So this is how it will elaborate. I'm guessing. I'm guessing this is what it means. Although I could be wrong because. Oh man. Okay. Fair. Let's see how to continue now. So, the block length. God damn, but do we use it actually somewhere then? Okay, so we get this. Determine whether the C block length is no longer than the IV. Bro, what the fuck is IV length? RGB IV. Block length is no longer than the. Wait! What the fuck is this? Wait, 1, 2, 3, 4. Oh my god, what is this, bro? RGB IV. Time to Google. RGB IV. It's. Wait, maybe I should read this. RGB. The fuck is that, bro? What the fuck? There's no documentation on this. Nice. I'm gonna die. But let's see, wait, actually. The following example shows how to encrypt data with CNG using an advanced encryption standard. Wow, that's all it says about encrypting it. Oh wait, encrypting data, okay. To encrypt data, perform the following steps. Open an algorithm provider that supports encryption such as, okay, although we do in AES. Create a key to encrypt the data with. A key can be generated by using any of the following functions. Okay, that's useful. Obtain the size of the encrypted data. This is based on the encryption algorithm, the padding scheme, if any, and the size of data to be encrypted. You can obtain the data size by using the... What? And the size of the data to be encrypted. You can obtain the encrypted data size by using the bcrypt encrypt function, passing null to the... Okay. Oh, okay, I see. So I'm assuming that this is actually what we're using here. Bcrypt encrypt. Yeah. Get the output buffer size. Wait, what? Oh, this is actually gonna encrypt it. Use the key to encrypt the... Oh no, okay. Whatever, let's not go that far. Passing null to the BP output parameter. All parameters must be the same as when the data is actually being encrypted, except for the BP input parameter, which is not used in this case, of course. You can either encrypt data in place with the same buffer or encrypt data into a separate buffer. Okay, if you want to encrypt the data in place, pass a plain text buffer pointer for both the PB output and PB input and PB output parameters in the bcrypt encrypt function. It's possible that the encrypted data size will be larger than the unencrypted data size. Wait, what? It's possible that the encrypted data size will be larger than the unencrypted data size. Oh boy. I'm actually going so hard on drugs right now because of AES that I have to reread multiple times a piece of text because I'm actually dying inside to understand it. Call the bcrypt encrypt function to encrypt data. This function will write the encrypted data located to the OK. Persist the encrypted data as needed. Repeat steps until all the data has been encrypted. Wait, what? Repeat steps. So this is not going to encrypt everything. This is just oh, I'm dying inside. But I still understand what this block length is. I actually have to maybe ask it somewhere. How to chain? No, this is not it. Simple way to encrypt file. No. What the fuck? Okay, let's see. Cipher encryption, decryption. Let's do this. Salt password. Okay, so this is the password. Okay, I'm guessing this is the actual key. Plain text array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Salt. Oh boy, this is gonna be a fun one. Also a long one. Encrypted data. Okay, okay, bro. Okay. So we're getting the handle. Then we're getting the oh my god, the key. Okay, the key length. No, never mind. Let's see. Create symmetric key. This gonna wait. I have to re-Google it real quick. Symmetric versus asymmetric encryption. Symmetric encryption. The encryption process is very fast. The encryption is. I'm guessing the symmetric is the one where we have the same key. A single key for both encryption and decryption. It requires two keys, a public key and a private key. Okay, that makes sense. Now we have to figure out quite a lot of things. What the actual hell is RGB IV? What is IV, bro? Plain text. RGB plain text. Plain text of what? What is this? Actually, wait, this is the same thing as here. Oh my god. Plain text array. Why? Why are we using it? This is being used in the encrypted data as the 1, 2, 3, 4. 1, 2, 3, 4. Plain text length. Wow, that helps a lot. But what is this being used as, bro? I don't understand. Be encrypt. Okay, address of the buffer that contains the plain text. Plain text to what? Oh my god, I'm gonna actually die. Bro, the plain text is supposed to be this. The actual data. What the hell? Why is this being called plain text? I'm such in a confusion. Plain text. Okay, the address of a buffer that contains the plain text. What? To be encrypted? Wait. AES. Plain text meaning. The fuck is plain text? The key size used in is the number of transformation around. Oh! But why is it called plain text? That doesn't make any sense. That just confuses us even more. Oh my god. Okay. Into the final output called ciphertext. The key size used for an AES cipher specifies the number of transformation rounds that convert the input. Okay. So if I want to online AES decryptor. Wait, what? How do you need just that? Wait, crypty. The good old crypty. Where is AES? Block ciphers. Okay, AES. Okay, and you have to put the IV and the key. Strangely enough, oh, maybe the IV. No, wait, what the fuck? Well, and what about the plain text, bro? What? How many inputs do I have to pass to this thing? Jesus Christ. Description of the ciphers. AES is based on design principle known as a substitution permutation network, and it's efficient in both software and hardware. Unlike its predecessors, AES fixed block size of bits and the key size. Okay, by contrast, per se specified block key size that may have multiple. Okay, AES operates on okay. State the key size. The key size used for an AES cipher specifies the key size. What the fuck? Okay. Specifies an rounds called the plain text. Here's the final output called the ciphertext. The number of rounds are as follows. Each round consists of several processing steps, including one that depends on the encryption key itself. A set of reverse rounds are applied to transform ciphertext back to the original plain text using the same encryption key. I'm not getting it. What the fuck is this plain text, bro? the information to be encrypted. Why are you called plain text then? What the fuck? If this is the information to be encrypted, then what is this? Maybe I should. Boy, I'm dying. What is this even used then? Wow. Wow. Google Docs, you amaze me every day even more. I just wasted like what, 10 minutes, 20 minutes I think, figuring out what this means, but actually not figuring out anything. Oh my god. Okay, so if we have like some kind of, okay, so if we have bytes, let's see. ASCII to decimal. Let's see, ASCII to decimal, and we're going to do, let's see, Microsoft Docs. Shit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So I have to say now convert this to hex, of course. Decimal to hex. Actually, I think I can use this. Base. No. Integer. No. Hex. Where the... Oh, the encoding. Wait, I'm blind. Encode as a... Fuck. Hexadecimal. No, that's being encoded the wrong way, bro. Whatever. Hallelujah. Okay, I found it. Thank you, YouTube. Thank you for removing the music. Okay, if I have this now, so this is hex. If I do the other way, hex to decimal, just check this real quick. Let's see, 6D. That's it, bro. Okay, now doing this will mean static count, byte, plain text. Okay, and we simply move this here. Easy as that, bro. Except we just have to fill it with the stuff. Oh god. This is very interesting shit, I know, right? Just filling stuff with colons and stuff. Okay, now if I could take this, let's see, and have it ready here for now, just for the testing purposes. That's okay. If I could paste, you know, that would be nice. Okay. Oh shit! I have to sign it. I mean, I have to tell it that it's like. Okay. You know what? I'm too lazy. Cyberchef it is, bro. Okay, this, and I have to tell it, pam, like this. Replace, bro. Find this and replace it with this, but like this. That's it. That's fucking it, bro. This is how I automate my shit. Yeah, don't judge. Okay. paste. Easy as that, bro. Come. Oh shit. Okay, now let's go here. This will be const plain text. Easy as that, bro. 1, 2, 3, 4, 5, 6, 7, 8. Is this the 8th one? I don't know, I forgot. Okay. Let's do it like this. Pump. Okay. Oh, this is actually a... Okay, cool. Wait. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's nice. We have the plain text. Now we have to put in some other stuff. Okay. I'll try to for now I think I'll remove this simply, just to for the sake of. Then static const byte iv, whatever the iv is, of course. I think it's some second password. I don't know. Wait, what the hell? An empty initializer is valid for the... Yeah, okay, whatever. Static const byte the key that we actually need, of course. Okay, and I'm just gonna copy this key because I'm too lazy to retype it or whatever. Being lazy is a good thing sometimes. Fuck! Not if the Vim clipboard doesn't work, goddamn. Okay, thank you. Also this, yeah, thank you. I also have to Google what this actual thing is. Wait. Okay, I think they're basically the same. Okay, I have to find out what this IV is. IV. Bro, wait. Salt. IV. The address of the buffer contains an initialization vector. That's what it's called. The used during the encryption. The initialization vector. The fuck? In cryptography, an initialization vector or starting variable is an input of a cryptographic primitive being used to provide the initial state. The IV is typically used to be random or pseudo-random, but sometimes an IV can only need to be unpredictable. Only needs to be unpredictable or unique. Randomization is crucial for some encryption schemes. Oh, because we have to use, okay, for randomization and shit. Oh, okay, whatever. I guess. Let's see now. Generate the key from supply. The input key bytes. So after doing this, wait, what the hell? We have to memory copy it. Okay, from where? Oh shit. Okay, Ubuntu time. If you could load. Are you serious, bro? I don't have the documentation for memory copy. Okay. Let it be online, okay, I guess. Okay, so here we're using memory copy and we're copying into from this. Okay, so we're copying, okay. And this is going to be how much, I guess. No, wait. Oh, again, the size of the key. That's nice. Okay. So if I open this, let's see, we need another PBIV. So basically IV, which will be up here probably as a p byte. IV bytes. I don't know. Okay, so memory copy into IV bytes, yeah, IV, and then the key object length. Okay, that works. Then after copying it, if we failed, okay, but I already did that check. So let's continue. If we set property, we're again setting a property, okay. So status bcrypt set property of algorithm handle chaining mode, bcrypt chaining mode. Oh wait, we are setting the property. Holy shit, I'm blind, bro. Bcrypt set property. Okay, so here we are setting the property. Let's see, bcrypt set property. Yes. The property input. Okay, so the address of a buffer that contains the new property, the size in bytes, a set of flags. Okay, simple as that, bro. So bcrypt chain mode. Okay, oh shit. What is this? If this could load a little faster, my G, please. We are 2023 almost, and I'm still facing latency. It says algorithms training mode to cipher block chaining. Okay, bro. Chaining mode to cipher block chaining, whatever that is. Block chaining, yes. Where? See cipher block chaining. What's cipher block chaining? I guess that's chaining blocks to encrypt. I mean, no shit, probably. Yeah. Bruh, I have to continue. Nah, man. What the hell is this? Okay, Wikipedia. Block cipher mode of operation. Cryptography block cipher mode of operation is an algorithm that uses a block cipher to provide information security. No. Oh, block cipher. Okay, wait. Actually, it's here. No, it's not here. It's here. Yeah. Cipher block chaining. Cipher block chaining, or CBC, is an advancement made over ECB since ECB compromises some security requirements. In cipher block chaining, the previous cipher block is given as input to the next encryption algorithm after XOR with the original plaintext block. Oh shit, okay, in a nutshell here, a cipher block is produced by encrypting an XOR output of the previous cipher block and represent plain text block. Holy shit, this is actually insane. Holy fuck. So you are storing it. Oh, with the IV. Oh, that's what the IV is actually. Now we can see. Okay, so this is how encryption works. Oh, this could be spelled right. P1. It takes the IV and XORs it together and then encrypts it with the key. And that's for the first cipher. Then for the second one, it takes this cipher and instead of the IV, it takes the previous cipher and XORs it with the next block. Then encrypts it with the key, and then it continues like that. Holy shit, this is smart. Okay, okay, I see what this is. Whew. Yeah, let's do it. That's what we are here to do. That's what AES is, you know. Okay, cool. Let's see now. Chaining mode and bcrypt chain mode. pbyte bcrypt chain mode. CBC, right? Yeah. Size of bcrypt chain mode. CBC. Okay. And then nothing because we don't have we don't need the don't worry flags. Wait, yeah, okay, cool. We set the status and then we have to simply check it. If status is let's see, lower than 0, simply the code error setting the CBC chaining property std and line. Okay. Next thing, wait, are we actually doing this correctly? Let's see. We firstly have to open the algorithm provider, which we did. Get the property of the key length, okay. Allocating it, which I did, then wait. Getting the property of the oh shit. We need something. We missed something. Wait. We are missing this step. Calculate the block length for the IV. Okay. This is hard to follow. And then after generate the key from supplied input key bytes. We have to see what this is. God damn, bro. Okay. Also, oh wait. Encrypt export key. Okay. Allocate the buffer to hold the blob. Export key again. Let's see. Size of. We're allocating it. Memory copy. Okay. Bcrypt encrypt. And here is hopefully the. Fuck no, it's not the last one. This is the last one. This is the end game, bro. Okay. Fair, bro. Let's see. Boy, this video is gonna be a long one. I think 2 hours or something. I'm not even sure if I'm gonna finish this whole thing in the whole video. So yeah. Oh jeez. Let's see. We are at this stage of allocating the heap, which is here. So then we have to get the property of the bcrypt block. Okay, let's see. So after doing this, we have to simply do status bcrypt get property algorithm handle bcrypt block length, because we're getting for the blocks block length cipher block length. Okay, and we have to pass the location here, cipher block length, and then we have to pass as a p byte. That's nice. And then a size of d word for whatever reason, and then status data, and then 0. Also that's bytes, right? Okay, that's very nicey. And then I have to simply check it. If status is this, SED code failed getting cipher block length property. SED and line. Okay. Okay. Now that I think about it, we don't need to even send them. I would just have to copy this. Oh boy, this is gonna be a long editing. Return false. Have to go here, do the same. Return false. Return false. Okay, like that, bro. False. Hopefully this is the last one, yeah. Okay. Now after getting the block length, we have to determine whether the block length is not longer than the So if it's longer, block length is longer than the provided IV length. So this fetches it as a in bytes, right? If it does, make sense. Okay, it says in bytes. Yeah. Okay. So if it's higher than the okay, yeah, because obviously, because if it's higher, then you don't have enough data to encrypt and shit. Okay, so if the where is it stored again? Oh shit, I'm too low. Oh, I have to put it here. If the cipher block length is higher, is bigger than the size of IV, we have a problem. SD code cipher block length bigger than the size of the IV. Okay, with that done, we have to allocate for the lovely IV. Then copy the IV. Okay, fair, because we are copying it. So simply, that's why we memory copied in the first place, because we firstly have to allocate it. So IV bytes, p byte, heap allocate get process heap, then 0 and size of IV, probably. Oh shit, no. I mean, yeah, okay, technically it could be done, but okay. Just for the sake of it, let's change it to key object length. Okay. If it failed, IV bytes, we have a problem. std count failed allocating memory for the IV. For the IV. For the IV. That's the end line. Okay, and return false. Pump. Now we have to set the property, the chaining mode. We actually already did this, so that's cool. Generate the key from supplied input key bytes. Okay. Now I have to Google actually this, because I have no idea what this does. bcrypt generate symmetric key. Hell yeah. Okay, we're doing 128 bits. Okay. The algorithm handle. Then we need the ph key, whatever this is. Pointing to the bcrypt key handle, receives the handle of the key. Okay, this handle is used in the subsequent functions that require a key, such as bencrypt. Okay, that's fair. So the handle to the key, basically. A pointer to the key handle. Char, lol. pb key object. A pointer to a buffer that receives the key object. So the cb key object parameter contains the size of this buffer. The required size of this buffer can be obtained by calling object length property. Yeah, that's okay. Yeah, that's what we already did. This will provide the size of the key object for the specified algorithm. This memory can be only freed after the ph key handle has been destroyed. Fair to know. So okay, this is gonna be the size in bytes. PB secret pointer to a buffer that contains the key for which to create the object. The PB secret parameter contains the size of this buffer. So this is gonna be the key, the actual key, right? Yeah, this is actually gonna be the key. Okay, that we're going to be using. Okay, cool. So now let's actually do this real quick. Bcrypt. Bcrypt generate symmetric key. Bcrypt generate symmetric key. Okay. Algorithm handle. Then we need the H key. So basically, this is some kind of handle thing. Bcrypt key handle. Bcrypt key handle. Key handle. Okay. So if we go here, we put the location of the key handle. Then we need the PV key object, and yeah, whatever, the size of the key object, or key object and key object length, and then basically the key. So okay, so p byte, the key and size of key, and then 0, because that's the don't worry flags, probably, you know. Oh yeah, the don't worry flags, of course. Okay, cool. Now if the status will be lower than 0, as always, we're going to complain std count failed to generate the key, std end line, and return false. Pam. Easy as that. Now we need to go to the next step, save another copy of the key for later. What? Why? Export key where? CB blob. But why? Oh, that's strange. Bcrypt export key. It's going to copy it to the PCB result, probably. Yeah. Okay. PCB result pointed to the ulong that receives the number of bytes that were copied into no the PP output. Wait, what? Why is it doing that though? Save another copy of the key for later. For what? You're not even saving it anywhere, bro. The address of the buffer that receives the key blob. The key blob. The size of bro, it's not even getting it. What the fuck? Bcrypt the opaque key blob. Okay, export a symmetric key in a format that is specific to a single cryptographic service provider. Opaque blobs are not transferable and must be imported using the same CSP that generated the blob. Opaque blobs are only intended to be used for inter-process transfer of keys that are not suitable to be persisted and read across versions of a provider. Bro, what the fuck is this, bro? It's not even. Wait. Export key. The handle to the key to which to wrap the exported key. It's exporting blobs. So otherwise, it's set to null. Yeah. Point is, why are we exporting it? We're just setting it to its. Bro, what the fuck? Okay, you're not actually. It's just to figure out its length, I guess. Because you're not actually saving it anywhere. You're just taking the number of bytes that were copied to the PB output buffer, which is basically null. It's null. This function will replace the required. Whoa, wait. Will place the required size in bytes in the ulong pointed by this parameter. Whoa, so it will give us the size of the required. Wait, it will give us the size in bytes. Okay, basically, that's basically the thing of H key. Okay, lol. So yeah, CB blob. This is probably a D word. yeah, ID word. So we have to go up here and do like key key blob length. Okay, we have to go down here and do the smart ass thing of doing status bcrypt export key. Okay, and then the actual key, which is hopefully okay, just the actual key. Wait, key handle. Okay, and if we go down here, export, yeah, exporting null. Okay, bcrypt opaque key blob null 0, then the location of the key blob length, and then 0 because don't worry flags, of course. Okay, and then if status slower than 0, std count failed exporting the key as blob. The end line return false. That's fair enough. By the way, the cold code is not gonna be actually these like this in the send codes. We're actually going to write the encrypt traffic, but for now I'm just keeping it like this to figure out how this all gonna work and how to implement it. But for now I'm just gonna keep it like this, bro. CB plain text. This is the size of the plain text. Okay. PB plain. Okay. Hip allocate. We're basically allocating for the. Okay. The thing for we're allocating enough memory for the thing. Okay. Plain text bytes, and also plain text. Let's see, plain text length, because we need it. Okay. Text length, size of plain text, which is this. Okay. Wait, what? Plain text length. Oh, bytes. No, wait, what? Plain test length. Okay, bro. I'm gonna rename this to text. I'm gonna go back and do plain text length. Thank you. And plain text bytes. Okay. P byte heap allocate get process heap zeros, because no, don't worry flags, and the bytes are gonna be plain text length. Yes. Okay, and if it's null, plain text bytes std count failed allocating memory for the plain text. Return false. Simple as that, bro. Then the next thing that we need, oh Jesus, this is getting quite long. 1 hour and half an hour. Okay, we're going to copy it. Okay, so memory copy from to, so from the, wait, yeah, no, the destination first. Okay, so plain text bytes, then the source, so plain text, and then how many? So plain text length. For some reason, wait, this is not actually getting it. What the hell? Plain text Allison, bro. Okay, since we have it already here, the size of, I'm just gonna, yeah, in the docs they could have just put this as the actual n, but whatever. Get the output buffer size. Okay, we are actually quite close to the end, I think. This is getting quite long. Jesus Christ! Imagine if this was actually not working at the end. Oh my god. I mean, we can try running it for now just to see if we get some kind of strange problems. Let's see what happens. Okay, everything seems fine. That's nice. Oh jeez, bro, I should take a break. Nah, I'm the Chad. I'm the coding marathonist. So yeah. What the fuck am I even saying? Okay, memory copy, get the output byte. Output buffer size, whatever that would mean. I think we saw this in the bcrypt, encrypt, like some kind of tip to figure out the size of something, but I forgot what was it. Null. The parameter option can be set to null if no array is used. Okay, now this parameter. If this parameter is null, the bcrypt calculates the size needed to be for the ciphertext. Okay. What is this? The PB out. The PB out is the fourth. 1, 2, 3. Yeah, and indeed it's 4. So get the output buffer size. So we are doing that. If this parameter is null, the bcrypt encrypt function calculates the size needed for the ciphertext of the data passed in the PB input, which is here, the third one, the plain text. Lol. What the fuck? That's the. Oh, okay, yeah, okay, it's okay, we're good. If the parameter is here, it's null, the bcrypt encrypt function calculates the size needed for the ciphertext of the data. Okay, the PB out parameter. In this case, the location pointed to by PCB result, which is this parameter, is not modified. Wait, what the fuck? Parameter contains the size, and the function returns status success. The padding info parameter is not modified. Checking for status would be useless here, but oh well, they're still doing it, I guess. So we're getting the PCB result, which is this, the ciphertext, and we're then using it somewhere, probably here now. Yeah, plain. Okay. Yeah, to allocate for the ciphertext, for the output ciphertext. That's cool. Let's just do it. Fuck it. Okay. So after the memory copy, it comes this actual part. So status, and we're going to bcrypt encrypt the key handle alongside the plain text, and the plain text length. Okay, this actually should have been like plain text bytes. Okay. Now let's see. After that comes null for whatever reason. Actually, should take a look at that. Then the IV bytes. Then the whatever this is, block length. Oh, that's the block length. Block length, I think it's called in my case. This is the thing that we're getting, yeah, here. So block length, cipher block length. Yeah, cipher block length. Yeah, that's what we're getting. So in here down, then we pass null because we want the size. Okay, and then the ciphertext. Ciphertext length, and then the bcrypt block padding. Now here are some things that I have to figure out and Google. First of all, I have to go up here and do this ciphertext length. Okay. Then we have to go down here. Ciphertext length. What the fuck? word is compatible with u long. Oh, because it's like that, okay. But in reality it's a D word, yeah, it's one of the first being declared, lol. Okay. Now. What are all of those parameters I'm interested in? So the H key, okay, the input, this padding info. I'm interested in this. A pointer to a structure contains the padding information. This parameter is only used with asymmetric, okay, keys and okay, basic stuff that we're not interested in. What is this? Is probably the address of a buffer that contains the initialization vector to use during the encryption. Okay, that's cool. Then the block length. Wait. PBIV. Okay, oh yeah, because size and bytes of the PBIV. Okay. Then we have the PB output, because we're setting it to 0. I mean to null. It's going to check. I mean it's going to realize the size. To give us the size of the ciphertext. Then we need 0 CB output. The size in bytes of the PB output buffer. What the fuck? This is in? Bro. The size in bytes of the PB output. Oh. No, wait, what the fuck? Of the PB output buffer. This is out. This parameter is ignored if the PB output parameter is not. Okay. PCB result. This one is going to be a hard one to understand later down, by the way, but okay. The PCB result that gets the result, okay, and the don't worry flag is that we actually don't care. Actually, in this case, yeah, what the hell is this? Allows the encryption algorithm to pad the data to the next block size. If this flag it's not specified, the size of the plain text specified in the CB input parameter must be multiple of algorithms. Algorithms block size. I think this will block and this will add them together if we have multiple of those. Like if the plain text has more how to explain this? God damn, bro. If it has more bytes than the required block, it will pad them together automatically. Also, encryption algorithm to pad the data to the next block size. If the flag is not specified, the size of the plain text specified must be a multiple of the. Oh yeah, it pads them together. It adds data basically. That's so that it's compatible. Whatever. I don't know. Jesus Christ, my brain is heating up, boys. Okay. Let's see. Then we allocate it with the given fucking thing. Okay, I have to go down here. Actually, not here. What the fuck? Here, and do ciphertext bytes, because we're gonna have to do the thing here. So I'm not even gonna check for the status. Actually, okay, fair. I'm gonna check if status below 0. STD count, I don't know, failed getting the size for the ciphertext. Lol. STD and line return false. Okay. Now the thing that we should do is ciphertext bytes p byte heap allocate get process heap 0 and then the don't worry bytes lol. Which are basically the ciphertext length that we are getting, and then if null ciphertext bytes, we failed to allocate them. SD count failed to allocate. Yes, allocate byte memory heap memory for the ciphertext and line return false. Okay, what the hell is happening here? Okay. Okay, now hopefully we are actually encrypting this shit. Use the key to encrypt the plain text buffer, and hopefully now after this we are done with this shit, bro. Okay, of course we have to also destroy the key and destroy the actual handle, but whatever. We are done. Use the key to encrypt the plain text buffer. Yeah. So status bcrypt encrypt key handle, then the plain text bytes, then the plain text length, then null because null, then the IV bytes, then the block cipher block length, yeah, then the ciphertext bytes, and then the ciphertext length. Fuck's sake, ciphertext length. This is where we are gonna get them right into, by the way. Then the CB data. Okay. Which is CB data, the fuck? Wait, this is the actual shit that we don't actually care about. Oh, lol, this is actual shit that we don't care about. Okay, so status bytes, status, I think I call it, I don't know, status bytes, yeah. Okay, and then 0. Wait, is it 0? Bcrypt block padding, yeah. Bcrypt block padding. Okay. If status below 0, we fail to encrypt. It's the count failed encrypting. STD end line. Return false. Okay. How about we now try to output this somehow? Let's see, how could we output this now? I mean, of course I could just print it with count, but I'm scared that would not be a friendly message. I mean, let's try encrypted stuff. Text. Ciphertext bytes. Let's try it. Fuck it. Okay, apparently it works. I mean, hopefully. I don't know. Let's see this. I'm pretty sure that this. It's not safe to just copy paste, but okay. Encrypt the. Let's see what's going on. If we can maybe decode actually this block cipher. Yes, as I know, we are using this one. Actually, I have no idea. Which AES are we using? Fuck's sake. Oh, okay. Hopefully this one. I don't know. Let's see. This text, and we are decoding it. This text, with the key being some fucking garbage. This. Oh, actually, I can just copy paste it like this. Very nicey. Must succeed. Oh shit. Fuck. Yeah, I have to copy paste it like that. Okay. Like this. Bro, I can't copy paste normally. Oh my god. Okay. CyberChef, where the hell are you? Okay. CyberChef. Okay. So now I'm gonna replace this with nothing. And I'm also going to replace this with nothing. Okay, now let's see. This goes in here. Okay, and we need also the IV. Copy. Oh god. Copy. Pam. Remove this. remove this. So I need this removed. I would also just do it like this. Okay, and the IVE. Fuck, the malformed content. God damn it. Hopefully I can. Okay, I can put this as byte, but how do I output bytes? C++ output bytes as hex. Let's see how to do it. I want to use C++ strings rather than C functions. You can use the following. Bro. So hex set fill. I guess I could do this. Okay, let's do it. Jesus Christ. Okay. Encrypted text. Let's just paste and go for, oh god, what the hell? Oh yeah, STD. STD as on hex as well. Okay, nice. STD on set fill. Not on set fill, I guess. I'm just gonna do it like this. Okay, array is going to be the ciphertext bytes, and this is going to be size of ciphertext bytes slash size of, actually just not slash, size of char, bro. Yeah, no. Let's try it. No, not really what I imagined. Fuck. Oh wait, we do get at least this part, but like no, I need hex converted. Oh shit, I'm stupid. It's not this, it's the ciphertext length that I need to do. Okay, bam. I need to restart it to get the full thing. Yeah, okay, cool. That's nice. I just need to convert this to hex now. Somehow. Convert char to hex in decimal plus. Hex and data. Okay. That's fair. So I just need to go here and do integer, and hopefully now it will work. That worked. Okay, cool. That worked. Now let's just test it out. Hex to ASCII. Yeah, that's what it is. Kind of. I'm seeing some similar letters, so let it be. I mean, what else can it be? Hopefully. Fuck. The question failed. Because of what? Because of what? I needed the. Okay, so this is the plain text. I need to get bytes. It's nowhere near what we set. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, F. This can be due to malformed content. Hmm. What if I try to encode it with this? Let's see what we get actually. So 6D. Oh my lord. I'm just gonna paste you here, well, in order to avoid the pain. Okay, like this. Let's see what we get. We get, ladies and gentlemen. God damn it, where is it? Oh, nice, 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 nice. We actually got the same thing. I'm surprised because I thought I was gonna wait. Oh no, it's okay, it's okay, it's okay. I'm actually very surprised because I thought that it failed somehow or something. But apparently it's okay. Now, the why this is not wanting to go there, I have no idea. Maybe because it's not this, it's this. This may be due to malformed content, bro. What the fuck? What are you talking about? It actually works. What? Oh, group by 1 byte. That is confusing as fuck. Imagine if that was the no. We need 6D 69 something. Ah. What do we get it as a string? That's nothing, lol. Okay. Shit. I don't want it as a counter. Did we maybe? No. We did nothing, bro. Like, look, it actually should work just fine. Either if something is wrong here, I don't fucking know. Look, if we take the plain text, and we take it here, pump, we get what we want. But if we try to decrypt it with this, it just doesn't work. What? Maybe I can try to do it online elsewhere. Decrypt 128 AES. Let's see, hopefully it will work. The text will be decrypted. Yeah, hex. Let's try this. This okay, the size of the secret key, and I need the IV as well. What the fuck? Oh, initial. Okay, cool. This and the key being this. Length of the secret key should be 16 for it. That's what it is, bro. Or maybe it's because isn't looking. Oh shit! No. What the fuck am I doing? It's correct. What? Online AES encryption and decryption tool. It would be cool if you could put in not strings but actual like hex. Hex, thank you. Hex key supported. Please, bro. CBC. The fuck is this? Okay, key hex values. Okay, let's see. I'm going to put this. This is going to be my key, and it's going to be my decrypt. What the fuck am I watching, bro? Oh, this, yeah, hex, okay. Encrypt we get somehow it managed to get this out from the given plain text. I have no idea how did you manage to get that, bro? That one out, bro. Wait, maybe. What is this? It would be useful if you could like tell us. It's literally the goddamn same, bro. Although yeah, this. I wonder why is this a thing? Because like why is it giving me a higher output than a longer output than my input? Well, shouldn't it be the same? I don't know. I don't know, bro. CBC. I'm using CBC. Yeah. What the fuck? No idea. No idea. What if I try to do this? This may be due to malformed content. What? Lol. Oh, I need this, yeah. What? Incorrect key, corrupt input. How? Where, bro? No. Oh, because I'm decrypting it. I should be. Yeah, I should be taking the other one. Oh shit! Let's go! It works. What the fuck? It works. Okay, that's cool. That's cool. Okay. You can see that if we go here and we do like hex decode online, and we try to decode the actual input that we're giving it, you can see that we get this. Okay, so it actually fucking works, and that's cool. That's cool. That's fucking epic. I wonder though what will happen if we remove this though. Would it encrypt it completely, or like would it fail, or just do the block? Well, I guess let's find out. No, it does the whole thing. Let's go! Holy shit! Okay, that's epic. That's fucking epic. That's fucking epic. Okay. Let's see if we can implement it into the I mean, if we can I can speak, bro. If we can implement it inside of this program. So we have our string, and oh shit, I'm actually fucking excited, bro. Okay, so we're gonna have an IV, a key. Okay, now I have to go. I have to change the plain text. The plain text is gonna be our codes. I mean our key message. Simply converted to string. So okay, let's just generate it simply. Let's see how to generate it. Wait, give me a second. Gotta set up some good music, bro. Gotta set up some good music. I'm not even sure if you can hear this music, but oh well. Okay, so I'm going to do like that's a good question. What to do even? Well, integer, I guess. Well, no, let's do byte. Byte, plain text, message. generate message bytes from the keys message. And if we go up here, we're going to do byte generate bytes from std string data message. And we're going to go for int I equals 0, I data message dot size I plus plus vector of byte output what the fuck? Don't I have vectors included here? Oh no, I don't. No, I do. What the fuck? That's strange. Just plus vector. Vector. Yeah, that's strange. Vector integer test. What the fuck? Identified vector. Identify vector is undefined. Vector is undefined. Why? Why me, bro? Using namespace std. God damn. Std vector byte test. Okay, new std vector byte. Is it how you do stuff here? I forgot. Like this. Like this, but without this. No, with this, Kevin. With this. Okay. Okay, so test that. No, not test. Output. Output. That push. Push back. Okay. Push back data message. That char. std string get character at index, yeah. At I. Okay, and then we return output dot vector get I need to convert it from a vector to actually just to an array. To array C++, yeah, that's what I want. Bro, seriously, I have to copy it. Oh no. Okay, fine. Let's do it. Okay, byte output bytes. Lol. Okay, output dot size. What the hell? Encryption must have a constant value. Excuse me. Then I'm going to do const integer out length output size. You can't defeat me and my power to do this. Fuck! It changes. What? Why? Cannot use size of vector for array length. God damn, I hate it when it happens. Says vector size to not, yeah, please, bro. As there says, the setting must contain a compatibility. Is it possible that the size of the vector may change during the runtime, so need to be constant? You will have dynamic array. Just you would have to make it a no, not the dynamic arrays. Fuck. I mean, it's actually what I can do. I don't know, bro. Could I? Fuck, I don't know. I don't know anymore. Okay, yeah, let's just return a byte pointer, bro. A byte pointer. That's doable. Return the address of, I don't know, bro, output first, like that. So it will generate, and I will take this. I don't want to trigger somebody. Okay, so yeah, let's just make this, and also have a size. Plain text message length here ready to be written to. So integer pointer length. So I'm going to write it there. So integer plain text message length is going to be equal to 0 for now. And here I'm going to set it to length to output that size. Okay, and once we have this, we can remove this. Actually, I'm gonna keep it, and then just replace whatever is using the plain text to whatever is using the plain text thing. So size of plain. Is this gonna be size of bytes? That's a byte. So I could. That's literally what it is. So I could just use that. So plain text message length. Plain text message. I'm just going to gonna do it the lazy way. Plain text. Memory copy. Okay. Plain text bytes. Okay. So I need the plain text message here. Okay. And I think that's it. Hopefully. Oh lordos! Okay, that's cool. That's cool. I think that's very nice, in my opinion. So if I go here. Actually, wherever I managed to decode this and take all of the lovely thing here we have, like this. Input cannot be decoded as try another. Bro, it should be. What do you mean? Am I even using the same thing? Oh Jesus. Oh Jesus. Okay, I think I'm seeing it correctly, but it's kind of missing something. I don't know what. What the hell is this? Input cannot be decoded as UTF-8. Try another character encoding. It's correct. What, bro? What the hell are you talking about? Yeah, this is the data, and fuck. But I think wait, is this? Yeah. So if I input it, for some reason it doesn't want to work. Wait, hold on. What if I put it here? Decode. Oh shit! It actually worked. No wait, what the fuck? It didn't work. Oh my god, Sakai. I'm gonna die. I'm gonna die actually. Oh wait, I can use chef AES decrypt. Okay, so remove this, throw it away, we don't need it. I'm gonna put it here. The key is this, and the IV is this. This is going to be CBC, output hex, input, it's hex as well. Okay, let me try to decode it now. Yeah, and in fact it is strange. It gets some of it, but like it's kind of missing. It's missing some stuff, which I have no idea why that's happening. Let's see if I can count it. STD count plaintext message length. Plaintext. Oh shit! I should do it here. STD count length. Plaintext message length. STD end line. Pum. Length. Okay, I guess. Also, I could try STD counting the actual message to just verify that. Keys message. Just to verify it. So here is the message. Shit. So it's saying that it's 900. Okay, characters counter online. It's 900 characters. So it's correct, but I'm feeling like there's some I fucked up somewhere. It's probably, I don't know, maybe because here it's plain text. Still searching it. Plain text. Let's see. Plain text length. Plain text length. Okay. Bytes. Plain text message. Okay, that's correct. Plain text length. Plain text bytes. Plain text length. No, it's completely right. Nope. I can see it working if we use like ISO or something. You can clearly see it that it's working kind of, but still something is missing. Like there's shit. I think I'll have to fix this in the next episode because it's been 2 hours, goddamn, and I have to take a break and then probably continue. So that was it for this video, for this long one. Jesus Christ, 2 hours, bro. Holy shit, that was a session. And yeah, hopefully I will be able to continue after the break and then maybe make another episode. Or maybe just finish this in peace and then show you once I'm done. So yeah,